Hello, YouTube. This is UMels03. In the previous lesson, we brought up the topic of modules, and we basically said that modules are basically sets of functions that someone has already written and implemented. And what we can do is simply go ahead and have an import statement at the top of our Python file, and that enables us to use some of the functionality that someone else has already been prepared. So that someone else has already prepared. So let's go see some examples of that. We were talking in the last video. I think I'm just going to start with a clean slate. You know, we've had a lot of examples of functions that I think you've been seeing in multiple videos over and over again. So let's start fresh. What we're going to do is we're going to say import math. Okay, so we can import a module in order to be use the functions within it, right? And then one of the things we did was we pulled up the API, right? We pulled up some documentation for how the math modules work. And so essentially, if you're looking here, we looked at all these different functions, right? So we could do math.ceil of x, right? So now we could figure out the smallest integer that's greater or than or equal to the input that's being passed into the ceil function, right? And then there's also factorial, floor of x, greatest common divisor, is finite, least common multiple, permutation. So there's a lot of good math functionality. So the question is, how do we use it? And we said that we need to go ahead and import the module. So now we can go ahead and say print of math.py. And the reason why that works is because modules can contain functions in them, right? There's lots of functions that we're going to be able to use and play around with, but there's also constants. So like if you scroll all the way down, we can see some different constants here. There's even one for infinity. There's a number that basically represents infinity. So these are some of the constants that are available to you. So math.py and math.e, and then you can go ahead and figure out what those values are. So what if you wanted to say pi equals, right? And then you wanted to get the value of pi. The problem is that we would not be able to concatenate a string with a double. We've seen that before. You can't combine a string and a float directly, so there's a type error here. But now if we go say string of math.py, then we can go ahead and convert that float variable to a string, and then it'll tell us what pi is, okay? And then so we can do that for functions too. So we could have said, you know, we could have said print of math.cosine of math.py, and we know that the cosine of pi is -1. So that's why you get the -1.0, because the cosine function is instructed to always return a float. Same thing with the square root function. What if you wanted to know the square root of 441? Well, you could go ahead and do that. And we said, if we import particular functions from a module, then we do not need to write the module name. So instead of writing math.square root of 441, if we specifically import square root, then we could just write square root. So let me show you what I mean by that. What we're going to do is we're going to reformulate this a little bit. So this is an example of using a direct module. But what I'm going to do is now I'm going to say from math import square root. So now what I could do is I could say print square root of 200, for example, and it would be able to tell me what that is, right? And you could go ahead and import more than one function if you'd like. So what if you don't just want to be able to use the square root function, but you also want to be able to compute a sine of a number? So you could say import square root and sine, and then I want one more. I also want the log base 10 of a number. So we're going to say log 10, okay? And we said that basically when we were talking about functions, if an input comes into a function, but it's never used, it's never called, it's never accessed, then it shows up in green, okay? So they're in gray, sorry. So that's why these are showing up in gray, right? It'd be the same thing as if you just said W equals 100, right? And so it's not really doing anything with that value of W, right? But here what we can do is we can say sine of math.py over 4, okay? And so here it wouldn't know what pi is because you didn't import the pi, right? But you could go ahead and import a constant too, and then you could just say sine of pi over 4, and so it would get the value of pi from the math module. Otherwise, it wouldn't know what pi is, right? So now if you go ahead and run main.py, we know that the sine of pi over 4 is the square root of 2 over 2, and that's the second number that's printed on the console, right? You could also have, you know, log 10. What if you want to do log 10 of 1,000, right? And then we know that that should be 3.0 because presumably log 10 would be instructed to return a float. With most of these numbers, these are going to be returning floats, even if it's something clean, right? Even if it's log base 10 of 1,000, and that would just give you 3 in math. But the float function, the log 10 function returns a float always. It's instructed to do that. And then the last thing we said is that we can call functions by other names. So we can call imported functions by other name using the keyword as. Okay, so what I'm going to do is instead of just importing these functions, I'm going to say import square root as s. Okay, Actually, let's just spell it out. Let's spell it out. So it's SQUAREROOT. Okay, so now it would have a problem with SQRT. So now what you would have to do is you would go ahead and talk about square root. Okay, you would have to spell it the exact same way. What if instead of spelling out SIN for sine, you wanted to just say S? So now if you say S of pi over 4, you would use math's definition of the sine function in place of S, right? And then pi, it would use math's definition of pi for pi there. So S of pi over 4 will be sine of pi over 4. And then log base 10, you could call that something else. You could say call that log if you want, right? So you could say log of 1,000. But that will give you different things you could do. You could even call the constant something, right? What if you wanted to call it PIE, like pi? And then you would have to say S of PIE over 4, right? And then you could go ahead and run it, and we would get the exact same results. Okay, so these are the takeaways, right? So then we can, we can say we can import entire modules, or we can import specific functions separated by commas using, from. So you would do basically from module name import function or variable 1 as, preferred name 1. And then you could say function or variable 2, as preferred name 2. And then you would basically then directly reference, preferred name 1 and preferred name 2 to refer to the functions, that you imported from the module, Okay, so hopefully that makes sense to you. And those are just a couple more examples. I wanted to actually show you one more module. Okay, so I wanted to show you one more module. So what we're going to do is we're going to take a look at random numbers. So there's also a module called random, and so this is really nice for generating random numbers. And there's different ways of generating random numbers. So if you look at the API, all you have to do, I'll show you how I got here. You go to blackle.com and then you do random Python module. Okay, and then it shouldn't take too much searching. It should be something from python.org. Okay, it's just a part of the documentation for the programming language. Okay, and so if you scroll down, you can see different ways of generating random numbers. So what I want to do is I want to look at this randint method. So if you call random.randint of a and b, it returns a random integer n such that a is less than or equal to n is less than or equal to b. So it returns some random number in that range inclusive of b. So if you say randint of 8 to 10, it would either give you 8, 9, or 10. Okay, so what we're going to do is we're going to import that. So what we could either do is we could just say import random, right? That's the name of the module. That's the name of the module. In the name of the function, you would have to spell it correctly. So now you could go ahead and say print of random.randint of 10 and 14. Okay, so that would either give us 10, 11, 12, 13, or 14. It gave us a 13. But then what if you just wanted to call randint? Okay, so you would say basically from random import randint. Okay, so now instead of saying print of random.randint of 10 and 14, you would just say print of randint of 10 and 14. So now you go ahead and run that, and then the code works the same way. What if you don't like that name? What if you wanted to call it random integer? So now you can't say randint here. You would have to call it what you said you were going to refer to it as, and now the code runs the exact same way. So these are two examples of modules, and you should go into the documentation and figure out exactly how those modules work for yourself. What we're going to do now is we're going to talk about exceptions. Okay, so exceptions are basically, we had a lesson in our Java curriculum about exceptions, but basically what exceptions are when our program diverges from the normal operation or from the way it was intended to run. So basically it's sort of a fancy word for error. Okay, they both start with E, and when you hear errors, you want to think of exceptions. Okay, so what we can do is we can actually raise exceptions. So this means that for any reason, at any time in the execution of our program, we can pretend that our program makes any particular error of any particular type for any particular reason. So let me show you what I mean by that. What we're going to try doing, we're going to talk about different types of exceptions. So here are the types of exceptions in Java. And I'm actually going to make a doc string out of it because we're talking about a multiple line comment, and I wanted to show that to you again. But usually we use these doc strings to describe functions, to provide descriptive explanations of what functions do, what parameters they accept, and what they return. and pretty soon what exceptions they raise. So we're going to be talking about that, but we're going to say types of exceptions. Okay, so we could be talking about a zero division error. Zero division error. Okay, and so what this means is that this means that you cannot divide by zero. So let's think about basically an example of when our program would throw an exception. So I'm going to delete this module work that we were doing above. I'm just going to delete everything, and we're just talking about exceptions now. So I'm going to basically say A equals 4, B equals 0, print of A over B. You can see that there might be an issue with this code, because in mathematics we say that it's usually not very cool if you try to divide by 0, right? And so indeed we have an exception. Okay, so this is a type of error that showed up in the code. Okay, and so if you had printed something else, if you had just wanted to print the value of B, this is totally okay. It can print 0, but the code's actually not going to make it to that point. But this line of code does not run because an exception was thrown beforehand. So this, this line of code throws a zero division error, and we call that a type of exception. Okay, so that's an example of an exception. Another type of exception that we have is an import error. So that would basically be basically a failure when you try importing a module. Okay, so what if you tried importing maybe a module that Python doesn't recognize? What if you tried importing the math module or the random module that we just talked about, but you spell it wrong? You say random. Okay, so now if you go ahead and try to run this code, you're actually gonna get a different type of exception, because we still have the zero division error in here, but there's actually an issue even earlier in the code. So it's actually gonna reach that error first, and so the module not found error. So that's kind of like an import error, but I'm just trying to demonstrate the different types of things that could go wrong within your code. You could also have an index error. Okay, a list is indexed with an out of range number. Okay, so this is another type of error or exception that would be called. So let's see an example of that. Let's go ahead and see an example of that. So what we're going to do, I'm going to keep this example in here. I'm going to keep my zero division error, but what I'm trying to show you is that Python programs run from beginning to end. So if there's another error, if there's another reason to call, to stop the program, the execution of the program before the zero division error, then, whatever error was first is going to be called out by the console. It's not even going to make it down. It's not even going to compute A and B if there's an error that happens beforehand. So then what you could do is you could say W equals 9, 1, and then the list 9 and 1. Okay, so what if you say print W of 3? Okay, the problem here is that even though the length of W is 3, there's 3 elements in this list. 2 of them are integers, and then 1 of them is a list of integers. But there's not index position 3. This is not a valid index position, because we said for a list of length 3, the valid index positions are 0, 1, and 2. So now if you run the Python executable file, it's still telling us that there was an import issue. But now if we go ahead and delete that, now we have an index error. And so we have a different type of exception that's thrown on the console. And therefore, if you try doing a calculation down here, right, you could print A plus B, you could print 4 plus 0. So let's see if we can even get a 4 here. And you can't even get a 4 here. Okay, so here, program execution stops because of the value error. Okay, so that's another example of a type of error that our program could suffer from, and that would prevent our program from continuing to run. Okay, there's also going to be called a name error. Okay, a name error is an unknown variable. An unknown variable is used. Okay, so what if I go ahead and say print of cats and dogs? Okay, and so I'm just basically assuming if you saw this line of code, the assumption would be that cats and dogs is some variable, right? It's been assigned some value in a previous line, right? But here, you're still getting the list indexing issue. So what I was saying is that these programs run from beginning to end, right? So it's not even going to make it anywhere near down here to this name error. So let's put the name error earlier in the code. So let's put it right on line 18. Okay, on line 18, I'm just going to scoot it up and then bring this one down. So now we can try to print this undefined variable, and you get a name error. So that's the type of exception that you see here. Okay. Another type of exception is a syntax error. Okay, so basically a syntax error would be thrown by the console if the code cannot be parsed properly. Okay, so I don't know exactly off the top of my head what a great example would be of that, but maybe if you didn't have a colon or something, right? So maybe if you said for x in range of 4, what if you said print of x, right? But here, we said that after, at the end of for loops and while loops and if statements and else ifs and things like that, usually we put a colon, right? So now if you go ahead and run this, Syntax error. It says, oh, range of 4. I think you need a colon after the range of 4. Okay, so that's another type of error that you can see. And then we also have a type error. Okay, so we have a type error. I think we've probably seen this before, but this is when a function is called on a value of inappropriate type. So one of the things we said is that the multiplication sign, right? It could either be multiplication or it could be multiple concatenation, right? So you could have said something like Adam times 5, you know, and then we're already familiar with this. That would print Adam, 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 right? And that would go ahead and, you know, you would have a hard time doing that because of all these exceptions in here. But what we would have to do is we would have to go ahead and remove these lines of code. So now let's go ahead and try to print Adam, 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 Adam. Okay, and it's able to do that right there. But what if you did Adam, what if you did Adam times 5.2? So now let's go ahead and run it, and you get a type error. And we get a type error here. It's another type of exception. We've certainly seen this error printed on the console before, but we haven't formally studied exceptions until now. So I'm realizing how long this video is getting already. We're just going to learn about errors, okay, and we're going to basically raise some of these errors in this video, but I'm not going to show you how to handle exceptions until the next video. The only other type of error we're going to talk about, this is getting to be a pretty long list, so a value error. So a function is called on a value of the correct type, but with an inappropriate value. Okay, so these are basically the types of exceptions. So these are basically the types of errors that could show up in red, and these errors have the effect of stopping program execution. Okay, so if an exception is thrown, it appears in red in the console. Okay, any subsequent lines of code will not be parsed after an exception. Okay, so the code before the exception will run, but the code after will not. Okay, so hopefully that makes sense to you, and we can study some of these examples, right? And we've already tried a couple of these, right? So we've already seen an index error, and I think we had basically something similar to an import error, and then we've seen a zero division error, right? And then we saw the name error, and then we saw syntax error, and then you could also talk about a type error. And so we've seen examples of most of these. Okay, and so what we're gonna try doing is, it turns out that you can actually raise an error. Okay, so what we were doing, I think I said a few minutes ago, we can actually raise exceptions. So this means that at any time in the program, we can basically pretend that our program is doing something that it's not supposed to be doing. Okay, so let me show you an example of that. Here we just have some single line comments, and then here I have doc strings, a doc string for the types of exceptions. And then all this stuff here is just demo code, so I'm going to go ahead and delete that. That's pretty bizarre there, but anyway, what we're going to do is we can go ahead and raise a type of exception. So what we're going to do is we're going to say raise zero division error. So basically what this line of code does is it basically tells Python that there is an issue where our code divides by 0. Okay, so this is pretend. It's kind of fun to be able to throw errors for no reason. Okay, it's not practical, but I just want to be able to show you how this works. So there's basically one line of code in this program if you exclude the comments and doc strings, and it just says raise zero division error. So now let's go ahead and try to run the executable file, and it says, right, it says that there's an issue here. So it says that there's a zero division error. Okay, so now what if you tried to print an ordinary line underneath it? What if you tried to say print of 3 + 1? So now if you go ahead and run the executable, it can't even make it to that statement. But if you had tried printing 4 + 1 before throwing the error, it would have been able to do that. You get the 5, but the exception prevents the 4 from being printed. And if you hover over this print statement, it actually tells you that the code is unreachable. Okay, so if you ever raise an error, if you just manually raise an error, but then you have code underneath it, you will not be printing that code, okay, because the exception prevents the program execution from continuing. That's literally what it does. Okay, the other interesting thing is you can actually pass in a string here, so we're going to see this, no dividing by 0. Okay, so we can actually pass a string into an exception, and so now we're going to run this Python file, and now not only does it tell us the type of error that we got, but it also gave us an error message. And so it tells us no dividing by 0. Okay, so these are exceptions, and I'm glad that we got a chance to review modules a little bit, but there's a lot of new content going on here, so we're going to talk about some of this stuff again in the next video, and also how to handle exceptions. What do you do? How do you basically solve a case where your program could throw an exception. So that's all for now from Emails 03. Thanks for watching, and please subscribe.